Originally, actually, I kind of built this with a scientific toy I bought online. It's called, radio by light. And essentially, it's a transmitter that you hook up to a laser pointer. It takes an audio signal, like a radio, and then transmits it as light. At the other end, you have a special receiver that measures the amount of light fluctuation and translates it back into sound. And what I realized is that if you actually transmitting basically no sound, but an insect flew past that laser and interrupted that laser, you would effectively hear the insect. So it's kind of like a optical recording of sound. But if you measure the sound optically, you can be completely deaf to external noise and only hear the tiny, tiny insects. I'm Eamonn Keogh. I'm the co-founder of FarmSense.
This is Code Story, a podcast bringing you interviews with tech visionaries.
Like 6 months moonlighting.
There's nothing at the backhand.
Who share what it takes to change an industry.
I don't exactly know what to do
took
next.
many goes to get right.
Who built the teams that have their back.
The company is its people.
The teams help each other achieve. I was proud of our team.
Keeping scalability top of mind.
All that infrastructure was
Yes, we've been fighting it as we grow.
Total waste of time.
The stories you don't read in the headlines.
It's not an easy thing to achieve, mind
Took it
you.
off the shelf and dusted it off and tried it again.
To ride the ups and downs of the startup life.
You need to really want it. Not just about technology.
All this and more on Code Story. I'm your host, Noah Lappart, and today how Dr. Eamonn Keogh has created an innovative solution for farmers that is the next generation of insect monitoring. This episode is supported by Terso. Terso is the open-source edge database from the creators of libSQL. Do you put your edge computing close to your users? You should put your data there too. Terso makes this easy utilizing the developer experience of SQLite. Access a free starter plan at terso.tech/codestory. Terso, welcome to the data edge. This episode is brought to you by our friends at MemberStack. MemberStack is the fastest way for you to launch a beautiful Webflow MVP with robust authentication and smooth payments integration. Join companies like Slack and American Airlines in serving millions of members every single day. Get started for free by visiting memberstack.com/codestory. Dr. Eamonn Keogh is a globally renowned expert in data mining, machine learning, and information retrieval. He is pioneering the field of computational entomology. But outside of tech, he's originally from Dublin, Ireland, but came to California in the 80s. He misses his family in Ireland, but he loves the cuisine in California, specifically Mexican food. I made sure to invite him to Texas, though, because we have great Mexican food. A perk of Dr. Keogh's job as a professor is he gets to play with toys, in his words. He picked up a science toy one day and decided to see if he could detect the sound from plant insects. When it worked, he decided to take it to the next level. This is the creation story of FarmSense.
For any crop that people grow, there's usually at least one bug that attacks that crop. Let me make this concrete for you. In California, we grow the majority of the world's almonds. We grow about 1.2 million acres of almonds here in California. And there is a bad bug. It's called the navel orange worm. It's actually a small moth. And it damages or destroys about $1,500 worth of almonds per year per acre. So you multiply that across, this is a multi-billion-dollar problem, and that's just one crop in one state. Now, growers can actually intervene with larvicides and other kinds of interventions to control those bugs, but they have to know when the bugs arrived, where they are localized in the field, often down to the level of sex and species and life stage of those bugs. This is really an information problem, and it's very difficult and expensive to get that information with classical mechanical insect traps. So FarmSense, we've invented this sensor. The grower can place a sensor in the field, and now the whole problem becomes digital. When the bugs arrive at the sensor, we detect them, we figure out if they're male, if they're female, what species they are, and so forth. This information is pushed to the cloud, so now the grower can simply go in the morning, wake up, open the iPhone or the laptop, and they can see where all the bugs are in the field and take the appropriate action.
Tell me about what you would consider the MVP, so that first version of the product you built. How long did it take you to build, and what sort of tools did you use to bring it to life?
Originally, actually, I kind of built this with a scientific toy I bought online. So there's a scientific toy you can buy. It's called, radio by light. And essentially, it's a transmitter that you hook up to a laser pointer. It takes an audio signal, like a radio, and then transmits it as light. At the other end, you have a special receiver that measures the amount of light fluctuation and translates it back into sound. That's kind of a cool toy to play with. And what I realized is that if you actually transmitting basically no sound, but an insect flew past that laser and interrupted that laser, you would effectively hear the insect. So it's kind of like a optical recording of sound you can use for insects. And the reason why it's important to do this optically and not with a true microphone is microphones are very sensitive to wind noise. And a small amount of wind noise outdoors will completely deafen you. But if you measure the sound optically, you can be completely deaf to external noise and only hear the tiny, tiny insects. About 7 years ago, the scientific toy kind of proved the concept in my lab that we could measure the sound of insects from a distance with very high fidelity. And then there was a question then of expanding this to be a kind of a practical commercial product.
Let's stay on that MVP for a minute. You chose to buy a specific, scientific toy. You chose to go about it in a certain way. And with that decision, there are trade-offs, right, that you have to make in the short term when you're trying to prove that concept. Tell me about some of those decisions that you had to make and how you coped with those decisions.
Fortunately, kind of in the beginning, it was just an intellectual curiosity thing. I had no kind of grand vision for a commercial product or a company. It somehow just kind of came out of intellectual curiosity. One great thing about being a professor, it's a wonderful job, is you can kind of play with things. So in my lab, I literally would play with Legos. I would play with, we had mice and insects. We had, all kinds of interesting things to play with. I can't claim any grand vision in some sense that I was going to solve this problem of pesticide use or world hunger or food production. It was simply just a question of, I have all these wonderful toys that make data. With AI, we love to play with data and what can kind of come out of this.
This episode is encrypted by CipherStash. Data breaches are becoming a fact of life. Know why? One of the reasons is because developers lack the right tooling to get the job done, i.e. encryption at rest tools are complex and inadequate. The solution? Encryption in use with CipherStash. CipherStash uses searchable encryption in use technology, providing continuous and universal protection for sensitive data. With CipherStash, you can turn your existing database into a vault, utilizing zero-trust key management, SQL native, and with no code. Though encryption is complicated, CipherStash is easy to use. The tool fully supports SQL via a drop-in driver replacement, supporting the query types you know and love today. And did we mention it's fast? For queries over 100 million records, you can expect additional overhead of less than 1 millisecond. It's a no-brainer. Get started by reviewing their docs or downloading sample projects in Rails or Node plus Sequelize today. Visit cypherstash.com/codestory and get started protecting your data. This episode is supported by Treble. This day and age, APIs are a fact of life. And as such, product and engineering teams need tooling that is lightweight, real-time, and data-rich to help them ship and maintain APIs faster. That's where Treble comes in. Treble is an all-in-one platform for the entire API lifecycle. The product offers world-class monitoring and observability, providing more than 40 data points for each request, enabling you to understand everything from performance to user behavior. Dashboards help connecting your entire team for lifecycle collaboration. Documentation is automatically generated, saving massive amounts of time for your development team with every new release. And setting up Treble? Super easy and fast. In 3 simple steps, you can be up and running with their platform. Their pricing is designed to support API teams of all sizes. So get started with Treble today and automate your API ops. Did I mention they have a free forever plan? Find out more by visiting treble.com/codestory. That's TRBLLE.com/codestory. So then you've got your MVP and it's working and you've got this idea. How did you progress the product from there? How did you mature it? And I'm curious about, in that process, how you built a roadmap, how you decided or went about deciding, okay, this is the next most important thing to build or to address with FarmSense.
One thing I kind of was helped by external advice is actually to kind of scale back my ambition a little bit initially, or to make some small incremental progress. So actually, I do have the ambition still that these sensors should be in every field, every crop, everywhere on the planet. I really believe that as a long-term vision. But, as one guy or a small company starting off, that seems to be intractable and untenable. So we decided to kind of narrow our focus on, if you pardon the pun, the lowest hanging fruit. And the lowest hanging fruit probably is tree nuts like almonds, pistachios, and walnuts for various reasons. First of all, they're mostly grown in our back garden, basically here in California. It's the most productive state in the world. And secondly, they're very, very sensitive to insects. And they're what we call a high value crop, unlike, let's say, corn, which is a much more low value crop with a smaller profit margin. We kind of understood that we actually have to solve one crop, one insect, do it very well, prove value to the world, debug all the issues that we have, and then begin to expand into new states, new crops, new insects incrementally. And now we're kind of halfway through that phase right now. We actually have looked at maybe 10 different crops and about 20 different insects. And every year we add in a new situation, a new insect, a new country, a new crop.
Okay, so how did you go about building your team? And what did you look for in those people to indicate that they were the winning horses to join you?
I've been unbelievably fortunate there because I'm not a generalist. I know very little about one thing, which is AI, and I was very good at machine learning, trying to figure out which bugs we see. But I'm not a hardware person. I don't understand embedded systems and sensors and wireless networks. Unfortunately, we have a wonderful PhD student here called Salandra Singh. And when he graduated, he wanted to do something a bit different than the classic, Google, Facebook type job. He wanted to be a bit of an entrepreneur. And I realized he had these wonderful skills that complemented my lack of skills in hardware. That was the first acquisition, and Salandra is a co-founder. At that point, we had, the hardware and the software, which in many companies is kind of enough, but we really are dealing with bugs, and more importantly, we're dealing with growers. And growers have their own way of doing things, have their own culture. They're not going to listen to computer scientists, and rightly so. So the next important person we brought on was Leslie Hickel, and she's a PhD entomologist from UC Riverside. And again, she understands not only how these bugs move, which is very important, but how the growers interact with the bugs, how they control the bugs, how they understand the bugs. And that really is our core team of 3 co-founders. We cover entomology, hardware, and software.
This episode was automatically optimized by Cast. If you run cloud-native software on AWS, Google Cloud, or Azure, you know how out of hand the bill can get. This uncertainty hurts your business, but you can solve it with Cast AI. Cast AI automates cloud cost, performance, and security management for hundreds of companies of all sizes. The platform's customers begin saving immediately and cut an average of over 60%. So before you go and sign a multi-year contract with a cloud provider or lay people off, check out what Cast AI can do for you. To get you saving even faster, Cast AI is offering a free cloud cost audit with a personal consultation. Visit cast.ai/codestory to get started. This episode is supported by Terso. Terso is the open source edge database from the creators of libSQL, the popular fork of SQLite. If you put your edge computing close to your users, like with Netlify or Vercel edge functions or Cloudflare workers, you should put your data there too, in order to maximize performance gains at the edge. Terso makes it easy. With a developer experience of SQLite and a distributed database you can replicate much closer to your users than traditional database offerings in the cloud. Terso's lightweight, easy to use, and free to get started. The team at Terso is offering a generous starter plan specifically for CodeStory listeners. Head over to terso.tech/CodeStory and get started today. That's TURSO.tech/CodeStory. Terso, welcome to the Data Edge. This will be interesting given what you're building. I'm curious where this sort of comes into the equation, but I want to ask about scalability. And if you built this to scale efficiently, maybe not from day one, maybe day 2, because I know the scientific toy probably wasn't scalable, but was it addressed to be scalable in the beginning, or are you fighting this as you grow in any sort of capacity?
Scalability has been and continues to be a bit of an issue. So initially, we actually have built all our sensors here in California with 3D printing. And 3D printing is a wonderful tool. I was kind of skeptical 5 years ago, but it's really kind of saved us dramatically. We've been able to 3D print maybe 500 or 600 of these physical devices and place them all over the world. But 3D printing is a scale above, actually going to a few hundreds was quite difficult. Going to thousands is impossible. We actually are offshoring now production, hopefully to China. We'd love to do it in America, but you probably know it's very difficult to do competitive fabrication here in America. So now we finally have all our injection molding type pieces, and we're actually ready to produce in China. Scalability is a bit of a chicken and egg paradox, right? Because if there is a huge demand, then you have plenty of the money, you can actually go and make something. We have to kind of prove it first to get the demand to justify the large scalability. So in the last 2 years, we have done paid field trials all over America and a few other parts of the world, and we really proved value. And now with that latent demand, we're able to get funding and inertia to actually go and scale up dramatically.
So there's a lot to be proud of here, but I want to know what your answer is. As you step out on the balcony, look across all that you've built, what are you most proud of?
Well, obviously, I'm very proud of my team. We just have a really amazing team. I guess what I'm kind of proud of is, people in AI, which is my area, they often work for companies like Google or Facebook, and they help, let's say, with computational advertisement. Nothing wrong with that. It's an important business. But at the end of the day, they're making somebody more likely to click on this ad versus that ad. And what we're doing with AI actually is, I think, really a win-win-win. What I mean by that is it's a win for the grower because it saves them labor and it saves them crop losses. It's a win for you and me because you actually have cheaper prices at the supermarket, at the restaurants. And it's actually a win for the environment because if the grower doesn't know what's in his field, he's tempted to actually spray the entire field with pesticide to kill all the bugs. And that solves his problem, but it also damages the environment. It hurts bees and pollinators, it hurts birds and bats and so forth. Our company, in principle, can reduce the pesticide use dramatically, and we'll win for the environment too. So I'm kind of really proud. I think it's a socially noble problem to solve. Apart from making people, a little bit of money, it actually is good for basically all players.
Well, let's flip the script a little bit. So tell me about a mistake you made and how you and your team responded to it.
One mistake that's all mine is basically kind of not starting sooner. So I've been flirting with this idea almost for 10 or 12 years, but I didn't really have the entrepreneurial, blood in my body, basically. And some external people, including my friend, Dr. Mihalis Falutsas, really kind of said, you have something really cool here academically, but it would make a bigger impact commercially. And I probably should have started sooner. I think maybe a lot of entrepreneurs will say that. And something else I think is not soliciting criticism and advice, right? As an academic, you tend to think, I'm the smartest guy in the room, I can do it all myself. And I now know that is not true, right? And especially working with a different culture like entomology and agriculture and so forth. So having people come and basically take a sensor and tear it to pieces and say, this will never work in my field, this will never work in the rain, this will never work on a hot day. And just basically kind of just constant criticism, seeking that and then being able to address it was really, really helpful. So it's painful, but getting criticism, getting advice is really, really important.
So this will be fun. What does the future look like for the product and for your team?
Future looks quite bright. Obviously, we have teething problems at any company. Our team is quite sparse. We've achieved so much with a relatively small team. So we do need to get some more people in the team and hire. Our basic roadmap, as I hinted earlier, is this kind of incremental growth, which is to every year do some new crops, some new insects. So, for example, this year, for the first time, we're going to look at berries for the first time at a detailed level. And then next year, we're going to look at other crops. We're also going to look at other markets, like invasive species. So insects not only cause problems in agriculture, but let's say in golf courses, there are things like Japanese beetles that cause problems for the turf. So there are additional markets we're kind of constantly trying to bring in too. Our ambition is very grand. We really hope to be in every field, everywhere in the world in the next 5 to 10 years. And even in places you might not consider. So, for example, insects cause problems in poultry farms, in dairy farms, by bothering the livestock and basically reducing their productivity. So bugs rule this world, and we want to be able to understand them and control them better. And again, if we can do that, it's a win-win for the animal health, for the farmer or grower, and for the and for us ourselves.
Let's switch to you, Eamonn. Who influences the way that you work? Name a person or many persons or something that you look up to and why.
I've been really kind of very fortunate all my life to have some great, mentors and advisors. I think the most important one was my PhD advisor, Dr. Mike Pisani at UC Irvine. Basically, when I was young, I used to grab a problem, try and solve the entire problem all in one chunk in one day, and often you can't, you just give up frustration. And he made me understand how you can basically decompose a problem. I mean, it's a classic computer science trick in some sense, but he really showed me how to do this very well, where you decompose a problem into bite-sized chunks and you solve a chunk at a time and make incremental progress. That kind of way of problem solving works academically, but it also works, I think, actually commercially too, right? If we tackled every bug on day one, we would have given up right away. But by limiting our ambitions and slowly, incrementally looking at more and more situations, we're able to make great progress.
If you could go back to the beginning, what would you do different? Or where would you consider taking a different approach? It doesn't have to be a mistake or something that went wrong. Could have went really well, but maybe you'd tweak it a little bit.
One kind of regret I have is just maybe not starting sooner, right? I mean, I probably should have done this, 10 years ago as opposed to 5 years ago. So I don't have to generalize to everyone, but not starting sooner. And I mentioned this before, but solicited advice and criticism really early on. For 1 or 2 years, I tried to kind of go it alone. And, getting the right team basically made a complete phase change. So people are the most important resource. I know everyone says that it's a cliche, but it really is true. And so getting the right people earlier would have actually sped me up a lot.
Eamonn, last question. So you're getting on a plane and you're sitting next to a young entrepreneur who's built the next big thing. They're jazzed about it. They can't wait to show it off to the world. Can't wait to show it off to you right there on the plane. What advice do you give that person, having gone down this road a bit?
One very kind of practical thing is there is this government program called the SBIR. It's surprisingly easy to get a bit of money sometimes from the government to start a company. That money is really helpful. Money is always good, but also kind of gives you credibility with investors to say, the government has kind of sometimes reviewed this and thought it's worth funding. We've actually won 4 or 5 grants now, and it's really helped us grow. One important thing is be willing to pivot. So originally, actually, when I started this, my interest in insects was actually mosquitoes and for human vector diseases. And I still have that interest, but it's now going to be pushed aside a little bit. It turns out actually that's not a commercially viable thing in some sense. It's more of a socially noble thing to do. There's more money in ag, so being able to pivot is a very important skill to have. And again, as I previously hinted at, getting help is very important. And there are many kind of sources of help. So it depends where you are. Many universities actually have people there who design to help entrepreneurial faculty. And we actually have some at UC Riverside. They've been very helpful to me. And they basically told me where I can get funding, where I can get help, where I can get temporary locations, where I can get industrial partners and so forth. So soliciting help is a very good idea, right? Don't be afraid to ask, basically.
That's great advice. Well, Eamonn, thank you for being on the show today. And thank you for telling the creation story of FarmSense.
Thank you so much. A lot of fun.
And this concludes another chapter of Code Story. Code Story is hosted and produced by Noah Labhart. Be sure to subscribe on Apple Podcasts, Spotify, or the podcasting app of your choice. And when you get a chance, leave us a review. Both things help us out tremendously. And thanks again for listening.
Taxes was feeling so stuck. Sitting in traffic, squeezing into a parking spot, all to squeeze in getting tax help during your lunch break. Now Taxes is a TurboTax expert who does your taxes for you, while you go about your day getting real-time notifications about their progress and the most money back guaranteed. Now this is Taxes. Intuit TurboTax. Get an expert now on TurboTax.com. Only available with TurboTax Live Full Service. Real-time updates only in iOS mobile apps. See guarantee details at TurboTax.com/guarantees.